Hello, my name is Joshua Frost, and I am an RU student at Georgia Tech, and I will be talking about the effect of particle size on the excavation behavior and tunnel geometry of Pagoda-Murimax oxide and talus ants. So it has been estimated that ants are able to use about 0.1% of the amount of energy used by modern excavation technology to excavate the same volume of soil. Due to this efficiency, we are interested in studying ant tunneling techniques to discover bio-inspired ideas to improve our own excavation technology, particularly of tunnels. One of the most important factors influencing tunneling behavior is particle size, so therefore this project is focusing on looking at the effect of particle size. So 4 experiments were set up with the sands of interest, which was the finer F110 and the larger Ottawa 2030. 2D chambers were used to observe the ants' excavation. So the F110 and the Ottawa 2030 were placed in the 2D chambers with different orientations, as you can see by this image here. After an equal number of workers were placed in each chamber, a high-resolution time-lapse digital photography system captured the process of excavation over 84 hours. And then MATLAB image processing tools were used to create binary images and also to collect the cumulative volume excavated. And then the cumulative volume excavated was then used to calculate excavation rates for every 3 hours. These images are the final binary images for each experiment after 84 hours of excavation. As you can see, they have varying orientations of the F110 and Ottawa 2030 sand, but we will just be focusing on this top image and this bottom image. So then these graphs over here correspond to the binary images and the 4 experiments. On this top graph, it is excavation rate over time. And as you can see, the ants primarily dug in the Ottawa 2030 for a time until they had access to the F110, at which point they started to dig in the F110 for a certain point of time, and then they started to excavate both sands for the rest of the test. In this bottom graph, once again, it's excavation rate over time. As you can see, with the option to dig in either F110 or Ottawa 2030, the ants primarily dug in the F110 for the majority of the experiment until they started to run out of space in the F110. So then they switched over to start excavating in the Ottawa 2030 for the majority of the rest of the experiment. So in conclusion, ants prefer the finer F110 sand over the Ottawa 2030 sand. This is explained by the F110 having a smaller particle diameter, a lower particle weight, and a lower interparticle capillary force than the Ottawa 2030 sand at 6% water content. Also, location of the sand does not appear to affect the preference for smaller particle sizes. And finally, ants excavate a certain percentage of sand based on total available volume, regardless of the particle size preferences. Thank you.